Is screen visible?
Yes, sir.
Okay, so what we discussed so far? So we discussed intermediate value theorem. So what is intermediate value theorem? I is an interval. F is continuous function. A and B are any two numbers in I, and suppose K is number between f of A and fb, then there exists C between A and B such that fc is equal to K. So continuous function defined on interval, then it attains everything in between, right? Also we saw that key if I is closed and bounded interval, f is continuous, and k is a real number such that k lies in between. So infimum of f of I, k, and supremum of range. Then there exists C belongs to I such that fc is equal to k. That means what this intermediate value theorem suggests, if your function is continuous on interval and you look at infimum of range and supremum of range, supremum infimum are actually maximum and minimum elements in this case, and if you take any k between, then there exists at least one c at which value is f of c. F of c is equal to k. Intermediate continuous function on interval attains everything in between intermediate values, right? That's why it is called as intermediate value theorem. So second, what we discuss, if f is function defined on closed and bounded interval is continuous, then what is the conclusion? Preservation of interval. So the range of f is equal to f of I is equal to small m to capital M, right? Or what is a small m? Is a closed bounded interval. That means range is also closed and bounded interval if domain is closed and bounded interval and function is continuous. So where what is small m? Infimum of f of I and capital M is supremum. So this statement is clear. Yes, is the statement clear?
Yes, sir.
Now suppose I is equal to AB, some closed and bounded interval, and F from I to rationals. What is a codomain here? Rational is a continuous function. Such that f of x naught is equal to 5 for some x naught in I. So what is a function? Function is defined on interval AB, or for simplicity you can take 0 1, but the function is defined on some interval AB, closed and bounded interval, and it is continuous, and codomain is rationals. That means function takes only rational values. Then what can you say about this function? At some x naught value is 5. Then what can you say about the function? At some x naught value of function is 5. What about the values of function at other points? Can you get any information? Yes. The question is clear what I am talking about.
Yes, sir.
So function is continuous and codomain is rationals. That means function takes values. So here f is rational, right? For every x in I. So this is a condition and function is continuous. So at some point value is 5. Suppose there exists y belongs to I such that f of y is not equal to 5. Suppose there is a point y at which value is different from 5, right? So given that x naught is in I and f of x naught is 5, correct? But there is y at which value is not 5. It is some value, whatever is f of y, correct? So by density theorem, there exists k belongs to okay, suppose, okay, let me say f of y is not equal to 5. So f of y is not equal to 5 means what is the possibility? Then either f of y is less than 5 or f of y is greater than 5. But what is 5? F of x naught, right? Suppose f of y is less than 5. Any one of them is fine. So f of y is less than 5. Then f of y and f of x naught both are in the range, correct? F of y and f of x naught are in the range of function, correct?
Yes, sir.
So now just concentrate on the range, the set 5 is f of x naught. So by density theorem, there exists k, there exists a rational, there exists an irrational number k such that f of y less than k less than f of x naught. Is it true?
Yes, sir.
Certainly, because f of y and f of x naught, which is 5, we are assuming that f of y is not same as 5 or f of x naught. So there is a k in between. Now function is continuous on I, that is our assumption. So by intermediate value theorem. What happens by intermediate value theorem? What happens?
It should take all values between f of maximum and minimum.
So it will take all values between fy and fx. Now that means if you there exist k, if you choose irrational number k between fy and fx naught, there are rationals, irrational, both are present in between fx. I will choose irrational number k, which is in between fy and fx naught. For that k, there exists c belongs to what? Y naught, such that there exists c between y and x naught, such that, or in domain such that what? F of c is equal to k. And what is k? K is irrational. So is it a contradiction?
Yes, sir.
Why?
Because our codomain is only rational numbers.
So we assume that key function takes only rational values and function is continuous. And why we get contradiction? Because we assume that there exists a y at which value is not equal to 5. Therefore, if value, so what is the conclusion? What is the moral of the story? Key function is defined on interval AB, and if it is continuous, codomain is rationals, or it takes only rational values. And if at some point value is 5, then is there a point at which value cannot be 5? Is it possible? There is no element in I at which there is no element in I at which value of f is different from 5. That's correct. And so what is the conclusion of this? F of x is equal to 5 for every x in I. And what is the conclusion? F is a constant.
So screen is frozen.
Okay, it may take time because there is a delay. But anyway, I will. Okay, so is clear what I want to say?
Yes, sir.
That means if function is continuous and if it take only rational values, then it must be constant function. No choice. Constant. Then by intermediate value theorem, being continuous, it will fill up everything in between. That means it will fill up irrationals also, which is not possible. That means function must be constant. Thus, if I is an interval and f from I to R, so whatever it is, closed, bounded, doesn't matter, is continuous. Okay, f is from I to rationals and it is continuous, then f must be constant. Right? So if function takes only rational values, it must be constant function. Now, the in the previous theorem, we saw that key function is defined on closed and bounded interval and it is continuous, then range is also closed and bounded interval. So next theorem is some formalization which is called as a preservation of, that means under continuous function intervals are preserved. Preserved means what? So let I be an interval. So now when I say I is interval, then it may be open interval, it may be closed interval, just interval. So if f defined on I is a continuous function, then the range f of I, what is f of I? The collection of all images is also an interval. Now what is the difference between this theorem and previous theorem? What is the difference? Do you realize there is some difference? Yes. So here we are assuming that I is just interval, maybe open, close, no matter. And the range is interval, maybe open, close, no, not sure. That means if domain is closed and bounded interval, then range is closed and bounded interval. That is a previous theorem. But what this theorem says, ki if your domain is interval, function is continuous, range is interval. It may be open, close. That is not certain about range. Right? Is it clear? Statement is clear.
Yes, sir.
Yes, sir.
Right. So, okay, what we want to prove? What is given? What is given? I is an interval. Therefore, I is of the type AB, or I is of the type open interval, or I is of the type A, B, or A, B. So it is any of the type. Remember this. Secondly, f defined on I is continuous. So it is our claim f of I is equal to the collection of images, right? Or range is an interval. Okay, so to prove that something is interval, what is the basic definition of interval? To prove that something is an interval, what is the basic definition?
We select two elements x and y in the interval, and the segment x, all the elements of the segment xy should be included in the interval.
Right. So our set A, which is range, which is f of I, we want to prove that it is interval. That means we choose any two from this set, and we will prove that line segment joining them. So this is my range A, right? I will choose two elements, so alpha and beta, and I will show that key anything in between. So let alpha beta belongs to f of I, and suppose alpha is less than beta, right? So what is our claim? The segment alpha beta. What is the segment alpha beta? Those element t says that alpha less equal t less equal beta is also contained in I, f of I in this set. So choose any two elements, no matter which alpha beta you select, just close your eyes and select. and then join them by a segment and check that the entire segment lies inside. That means the f of I itself is interval because it contains everything in between. Okay, so I have selected alpha and beta in f of I. So since alpha and beta are in the range, that means they are in the range means they corresponds to some elements. So there exist a and b in I such that alpha is equal to f of I and beta is equal to f of b. Correct? Because alpha and beta are in the range. In the range means they are images of some elements. So alpha is image of A and beta is image of B. Correct? Yes. Do you agree? Now let. So to prove that this entire segment alpha beta is inside f of I, that means if I choose any k, if I choose any t between alpha and beta, alpha less equal t less equal beta, that means f of a less equal t less equal f of b because alpha is f of a. So by intermediate value theorem, intermediate value theorem, what happens? F of a, f of b, t lies in between f of a and f of b, and f is continuous. So by intermediate value theorem, there exists C belongs to what? Domain such that f of c is equal to t. Now I select any element from alpha in between alpha and beta, and I found that there is a c in the domain whose image is. So ultimately, what happens? Can I say that t is in the range? Because t is image of some element in the domain. Correct? Thus, for every t in between alpha and beta, we have t is member of f of I. What is the conclusion of this? The entire segment is inside f of I. Yes.
Yes, sir.
And so what is the conclusion for any alpha beta? We didn't select alpha and beta specific elements. So just arbitrary select and we found that the entire segment is inside. Thus, f of I is an interval. So f of I is an interval. Correct. Now question, so note this. So if I take function from open interval 0 to 2 pi to r, fx is equal to sin x, right? What is my interval I here? What is my interval I? 0 to 2 pi open interval, and function is sin x. Now you tell me what is f of I? What is this set? Just observe the graph of sine function and you tell me what is. Do you see the figure?
Yes,
Yes.
sir.
So now you tell me what is the range of this function. My domain is
Close
0 to,
interval to 1.
right, close interval -1 to 1 because it attains everything between -1 to 1. So domain is open interval, but range is closed interval, right? So sometimes it may happen that look at another function. If I define function on to r, fx is equal to x, then what is f of I? What is the range?
Open interval 0 to 1.
Right, open interval 0, 1. That means if function is continuous, domain is interval, range is interval, but if domain is open interval, it may happen that key range is open interval or close interval. Right, it may happen that uh, domain is open interval or close interval. But if domain is open interval, then range may be open or close. But is close interval, then range is close interval. That is the certain thing. That difference you should realize. Or you look at another function, f from r to r, right? F of x is equal to 1 upon 1 plus x square. And if you see the graph of this function at 0, this is 1, and at other, if we extend it to plus infinity and minus infinity, it goes towards 0. So this is a function. Now what is f of r? What is the range now? What is the range?
Open at 0 and closed at 1.
Very good. Open at 0 and close at 1, because it attains value 1, it never attains value 0. So the domain is whole R, but range is not open interval, not closed interval. It is one end open, another end is closed. So that anything is possible, because your domain is not closed and bounded. But what is a certain thing? If domain is closed and bounded interval, certainly range is, so that difference you should note. So we'll see very interesting theorem basically. So which is called as fixed point theorem. So what this fixed point? Suppose you have a ball, football or whatever ball you put in your hand and you just rotate it. What happens? You take a ball and rotate it. Do you observe that there is a point? There are 2 points actually, which are fixed, or there. See, if you rotate the ball, the position of points on the surface of ball positions will change. You understand?
Yes, sir.
But there are two antipodal points, or 2 points on opposite sides. They are fixed, right?
Yes, sir.
So how to understand this phenomenon mathematically? So using calculus, certainly you can understand. And the theorem is called as a fixed point theorem. So, or if you look at the temperature on surface of Earth, there are two antipodal points on the surface of Earth at which temperature is same. Right. It always happens on the surface. So this phenomenon can be understood using calculus. So this is called as a fixed point theorem. And what this fixed point theorem says, suppose, so I have a function on interval 0, 1, and suppose its range is also 0, 1, or codomain is 0, 1, right? And suppose function is continuous. Okay, this is line y is equal to x, and I have some function. So suppose f from 0 1 to 0 1 is a continuous function. Right? Suppose my function is continuous, and what is the restriction? Domain is close interval 0 1, and what is the range? Codomain is 0 1. That means range is inside. So that is range is not exactly 0 1, but what is the range of f, which is f of I, is inside. Do you understand? The range of function is inside 0 1, because codomain is 0 1. It will not go outside 0 1. Then, and function, yes. Can you draw the graph of function which do not intersect line y is equal to x? Is it possible? Can you draw a graph of such function which do not intersect the line y is equal to x?
No, sir.
So you should try to sketch the graph of such function anyhow. It must intersect the line y is equal to x. And what is the speciality of that point of intersection? What are the coordinates of that point? What are the coordinates of that point? It is
0,
on the line
x.
y. So this point is on the line y is equal to x. Therefore, coordinates are c comma c. But also it is on the graph of function. So the y coordinate is f of c. And therefore, what is the speciality? The value of function at that such c is itself. Then there exists c belongs to 0 1 such that f of c is equal to c. The statement is clear. Statement is clear.
Yes.
Yes, sir.
That means the point c is a fixed. So point c is fixed point of f. Point c is a fixed point of f, means doesn't change, right? Or a point alpha is a fixed point of function f if f of alpha is equal to alpha. Fixed point means value doesn't change. The value of function at the alpha is same as alpha. So function maps alpha to alpha, fixed, right? So therefore, if function is continuous on interval 0 to 1 and range is inside the domain itself, inside domain, range is inside domain. That is what the meaning. Then function has, and geometrically it is easy to understand ki if your range is inside 0 1, if there is no restriction, you draw the line y is equal. But our restriction is range is inside 0 1, so you have to draw the graph in this square. So it must intersect line y is equal to somewhere. No choice. Okay, so how to prove this? So what is given? F is defined on 0 1 to 0 1, right? Secondly, f of x belongs to 0 1 for every x in the domain, right? That is 0 less equal f of x less equal 1 for all x. Every value lies in between 0 1. Fine. So what is our claim? What is our claim? There exists c between 0 and 1 such that f of c is equal to c. Okay, so to prove this, what is our strategy? We want to use previous theorems which we already proved. And which theorem is useful, that you can understand from the graph. Key, if I define a function which is a difference of fx and line y is equal to x, and where this difference 0, where is the difference
At
0?
C.
At C. And what is the difference means what? Define a function g on same interval 0, 1 to r by g of x is equal to fx minus x. Fx is already given function, and using that I am defining new function. So fx minus x. Then what are the properties of g? Is g continuous?
Yes, sir.
Right? So it is continuous because f is continuous, x is continuous, so difference is continuous. Second point, what is g of 0? What is g of 0?
F of x.
So f of 0, right? F of 0
Yes, sir.
minus, but where is f of x? F of x is greater equal 0. That means g of 0 is greater equal 0. Because g of 0 is f of 0 and f of 0 is greater, because at every x in interval 0, 1, f of x is greater equal 0. And what is g of 1? F of 1 minus 1. And what is the sign of f of 1 minus 1?
Negative.
Because for every x in 0, 1, f of x is less equal 1. So f of x, in particular for x is equal to 1, f of 1 is less equal 1. And therefore f of 1 minus 1. So f of 1 minus 1 is less equal 0. So if g of 0 is equal to 0, or g of 1 is equal, if f of 1 is equal to 1, if f of 0 is equal to 0 or f of 1 is equal to 1, then nothing to prove. Correct? Do you
Yes,
understand?
sir.
If f of 0 is 0 or f of 1 is 1, then nothing to prove, because then 0 or 1 is a fixed point. We found a fixed point, nothing to prove. But the case is non-trivial if. So if neither f of 0 is equal to 0 nor f of 1 is equal to 1, then what happens? 0 less than, so then 0 less than f of is strictly less than f of 1 for all every x in 0, 1. That means for f of x is strictly greater than 0. Okay, not strictly what I want to say. If neither f of 0 is 0 or nor f of 1 is 1, then what happens? Then 0 is strictly less than f of 0, and f of 1 is strictly less than 1, because f of 1, f of 0 are greater equal 0 and less equal 1, but f of 0 is not 0 and f of 1 is not 1, then that is a non-trivial case. That means f of 1 is strictly less than 1 and f of 0 is strictly greater than 0. Do you understand? what I want to say?
Yes, sir.
So that what about g of 0 is f of 0 is strictly positive, and what about g of 1 is f of 1 minus 1 is strictly negative. So g is continuous. At 0 value is positive, at 1 value is negative. So which theorem we can apply? Which theorem we can apply? So g of 1 is negative, g of 0 is positive, or g of 0 into g of 1, sign is negative and g is continuous. Then what happens? Which theorem we
There
can apply?
exists a C.
By location of root theorem. G has a root in between 0 and 1. There exists C between 0 and 1 such that g of c is equal to 0. But what is g of c? What is g of c? What is g of x?
F of C minus C.
Right, f of c minus c is 0. That means f of c minus c is 0 means f of c is equal to c. Thus, there exists c in between 0 and 1 such that f of c is equal to c. Right, so if f of 0 is equal to 0, nothing to prove, or f of 1 is equal to 1, then also nothing to prove, but neither f of 0 is 0 nor f of 1 is 1, then also there is c. So in any case, we can always find a point at which function has a fixed value. So c is a fixed point, right? Now, more generally, suppose we have a function on AB to AB is a continuous function. Now, not 0, 1 interval, I am just taking any interval AB, A to B, and in codomain A to B. So function is defined on AB and its range is also inside AB, and therefore you look at the line y is equal to x. Right. So what are the coordinates of this point B comma B? What are the coordinates of this point A comma A? And therefore you look at the line y is equal to x. It passes through diagonal. That means it passes through these opposite corners. Now, how will be the graph of this function? So domain is AB, codomain is AB. That means graph must lie in this square, right? Graph should not go outside the square. That is our restriction. And therefore, if you try to sketch the graph, it must intersect line y is equal to x. That correct. What are the coordinates? C. But since that point lies on the graph, so it is f of c. Do you understand? Yes, from the figure it is clear.
Yes.
So then there exists c between a and b such that f of c is equal to c. And it is just similar to the previous one. So you can similarly prove it. Right. Similar proof, same proof. You just write down the proof of this. Correct. So So let I is equal to interval AB and f is from I to R. G is another function from I to R. Be continuous functions. Suppose f and g are both continuous function defined on closed and bounded interval. So let S is equal to those elements from domain at which fx is equal to gx. Right. So if xn is a sequence in S such that limit of xn is equal to x naught, then prove that x naught is in S. And same problem we discussed before, right? Do you understand? Same problem we discussed earlier. Yes. Similar problem, not same, similar problem. This f and g are equal at some points, and if is a sequence set S and x naught is a limit, then x naught is also a member of S. So what problem we discuss? So let h be a function defined on AB, and what is h of x is fx minus gx. Suppose I define this, then h is continuous. Is it true?
Yes, sir.
So h is continuous. And what is set S? X belongs to I such that h of x is equal to 0. Is it same as the set of all points such that fx is equal to gx?
Yes, sir.
Right. And so if xn is a sequence in S and limit of xn is equal to x naught, right? Then what will happen? Then can I say that xn is a sequence in I interval AB,
Yes, sir.
because it is in S and S is a subset of I. So xn is a sequence in closest interval AB. Therefore, limit of xn. So limit of xn is x naught is also in the closed and bounded interval AB. Correct. That is why we call it as a closed interval. So limit of sequence remains inside AB. If you walk in the interval along sequence, we cannot go outside, means the limit remains inside, that we already discussed. And so since x naught function is continuous everywhere, so h is continuous at x naught, right? And therefore by sequential criteria, what is limit n tends to infinity hxn? What is it? Correct? Is it true?
Yes, sir.
But what is xn? At xn, what is the value of function?
0.
But hxn is 0 for all n, because xn is in S. Therefore, what is h of limit of xn is 0, but what is limit of xn is x naught, so h of x naught is 0. That means x naught is member of set S. That's it. The similar problem we discussed earlier, right? Okay, so one more problem. So let f be a continuous function on 0 1, right? F is a continuous function on interval 0 1, and f of 0 is equal to f of 1. So value of function at 0 and 1 is same. So prove that there exists C in 0 1, there exists in 0 to half basically C in 0 to half such that f of C is same as f of C plus half. See what this theorem, what is the significance? Function is defined on 0 1 and it is continuous, and value of function at 0 and 1 is same. So function is defined on 0 1, value of function at 0 and 1 is same, right? Value at 0 and 1 is same. That means f of 0 is same as f of 1. From figure you can understand this. Then there is a C in half between 0 and half such that value of function at C is same as value of function at C plus half. So C and C plus half or half plus C. So whatever. So value at these 2 points is same. So this is a very interesting thing because if you go by half distance from C, you will come to the same value. That means if you moving on the earth and you notice there are 2 points on the earth surface, let us call as C or angle if you look at it as angular moment. So then there is a point if you go exactly on the opposite end at which temperature is same. So that means at any time antipodal points on the surface Earth's equator have the same temperature. If you move along the equator of Earth, then there are two antipodal points at which temperature is same. So that phenomena is true in real life also, and there is a calculus involved in it. So how to prove it in using calculus? So G, suppose I define a function G on 0 to half, right? I define a function 0 to half such that g of x is equal to fx minus f of x. So this is my function. And this function is well defined because I vary my x between 0 to half. So f of x plus half varies in between 0 to 1. So f of x plus half is also well defined, no problem. Then what happens with g? So g is continuous on 0 to half. Is it true?
Yes, sir.
G is continuous. Now what is G of 0? Is f of 0 minus f of half, right? So G of 0 is equal to f of 0 minus f of half. And what is G of 1? F of 1 minus, no, what is G of 0? So, okay, what is f of half? F of 1? No, 1. What is f of half actually? What is f of half? G of half basically, because 1 is not in the domain. What is G of half?
F of half minus f of 1.
F of 1, right? So but f of 0 is same as f of 1, so it is f of half minus f of 0, correct?
Yes, sir.
So therefore G of 0 is f0 minus f half, and G of half is f half minus f0. Now if f of half is equal to f of 0, then what we have, f of half minus f of 0 is equal to 0, right? So that the C is equal to which point we will select?
0.
0, and we are done. But if f of half is not equal to f of 0, then what will happen? F of half minus f of 0 is not equal to 0. That means f of half minus f of 0 either positive or negative, right? Suppose f of half minus f of 0 is positive, right? Any one of them, either you assume positive or negative, whatever is, then what will happen? What is G of 0? Is negative, and what is G of half? Positive, correct? So is it correct?
Yes, sir.
So by location of root theorem,
There exists a C between 0 and 1 such that
right,
G
there
of C is
exists
0.
C between 0 and half such that G of C is equal to 0. But what is G of C? F of C minus f of C plus half is equal to 0. That means f of C is equal to f of C plus half. That means there exists C between 0 and half such that Fc is equal to f of C. So this is a very interesting thing. Ki if you go half distance from C, you can come across the point where value is same. Such C always exists. It is not true that ki, see, remember that it is not between 0, right? It is not true for every C in between 0 to half. There is a particular C. Uh, Look at C plus half, then temperature is the value is same. Such a specific, very special C exists. Exactly same thing happened on equator of Earth. There is a point. There is a specific point. If you look at that point and temperature at that point, and if you travel exactly half of the perimeter or circumference of equator, then you will cover the opposite on the Earth surface, which is on opposite side of equator. Temperature is same, right? So if you look at the sphere of Earth, there is a specific C. If you go on opposite end, the temperature is same. Right. Okay, is this clear?
Yes, sir.
Okay, now we'll stop here. We'll discuss more about it during the practical session. It will discuss more problems on it during the problem session. Practical session. So if you have any doubts, you can ask.